All right, I believe we are on problem number 3, or example 3, yes? So, what we're doing is solving these 3 variable systems of equations. We want to find a solution that will make all 3 statements true. And to do that, we're going to take it from 3 equations with 3 variables, down to 2 equations with 2 variables, down to 1 equation with 1 variable. And when we look at this here, we want to find a variable we can eliminate out first, either x, y, or z. Which variable do we want to eliminate first? X. And we're going to pick an equation to eliminate it with. Now, for this here, we would pick one of the equations where x is either 1 or we can turn x into the other 2 equations easier. So that we picked that the top equation is our eliminator equation. We'll write the other 2 underneath it. We'll just write them down, because we're going to eliminate x out of these 2 equations. Now for the one on the left, x is already the same. We have 1x and 1x. We don't have to do anything to it to make it be like the other 2. Now this here we can either add or subtract, because we want the x's to become 0. So if we add, x plus x is 2x. So we're not able to add these 2 together, but we could subtract, because x minus x is 0. So since subtracting made it so that those variables, the variable x cancels out, we're going to subtract both equations from each other. So x minus x is 0. We'll look at the next one. Negative y minus negative y. Well, here the negative and negative would make a plus. Negative y plus y is also 0. Negative z minus z. Well, that's going to be negative 2z. Negative 3 minus negative 3. Well, the negative and negative make a plus, and tell us that it is 0. Well, at this point here, we can go on and solve for z. We can divide both sides by 2, and it tells us z is equal to 0. Yes? Now this here is kind of helpful. We already found out what z is. We know z's value, yes? That means I could plug it into this other equation, let me write, and then we can use this new equation with our eliminator equation, which is our x minus y plus 0 equals negative 3. We're removing x or z from it because we already know the solution. Well, this equation here, we'll bring it down. It's going to tell us that we have 5x minus 5y equals negative 15. Our eliminator equation, now that we plug that in, is now x minus y equals negative 3. Now we can keep going with this here and eliminate x. But what do we need to multiply this equation by to get the x's to be the same? 5. 5 times x is 5x. 5 times negative y is negative 5y. And negative 3 times 5 is negative 15. Questions on this here? Now at this point we can subtract. 5x minus 5x is 0. What's negative 5y minus negative 5y? 0. So the whole left side is 0. Negative 15 minus negative 15 is 0 equals 0 true. So we have a true statement and we have a value. Infinitely many solutions. And that's as far as I will have you all take this. Now there is a set equation that we have that will define the solution set. It actually works out to be x plus 3, and 0. So everything on this here, for any given value of x, we would have a solution. And there's infinitely many of those solutions. Once we get this here, we have a true statement, 0 equals 0. And the other side, eliminating the other variables, did not give us a false statement. We have infinitely many. Questions on this here? Or especially if, because if we kept going the way we were before we plugged in z equals 0, it would have told us that z was 0 again. It would have told us both sides would have told us that z was 0. Infinitely many. Questions on this here? We're going to look at 3 more. This next one here, we have our 3 variable, 3 system, 3 equations. Which variable do we want to eliminate first? X, Y, or Z? Because either one, X, Y, or Z, all of these are going to be nice, yes? Because if we look at the top one, we can turn X into 3X, and X and negative X both are already 1, so that works out nicely. These two Z's are already the same, so that's fine. And I can easily turn either one of these Z's into 4, so that we can eliminate it. And then 2, well, these are the same, yes? And actually, these are the same. So which one's going to be the easiest one to eliminate out first? Why? Because all the values are all 2. Top, middle, bottom. Which one do we want to be the eliminator equation? The one that we eliminate the y out of the other 2. Top, middle, bottom. Middle. So that's our eliminator equation. We can write the other 2. X minus 2y plus z equals negative 11. Negative x plus 2y plus 4z equals negative 9. Now, since we're eliminating y and the y values already match up, we can go on and just fill these in. Questions on how we set this up? So on the left one here, we said we're going to eliminate y first. If we subtracted negative 2 minus 2, negative 2 minus 2 is negative 4, yes? We wanted it to be what? 0. So we can't subtract. We'll most likely have to add. Negative 2 plus 2 is indeed 0. So here we're going to have to add these equations together. Now x plus 3x is 4x. Negative 2y plus 2y, negative 2 plus 2 is 0. Z plus negative z, 0, equals negative 11 plus 7 is Negative 4. Wait a minute. We already have a variable by itself, don't we? So we can go on and solve this for x. So we can divide both sides by 4. And it tells us x is negative 1. Now we could plug the negative 1 into the other equation. I did it on the last one mainly because I knew if we didn't do that, it would have just told us z equals 0 again. That it's going to be infinitely many. But here, we don't have to worry about that. And normally, I would just keep plugging along as is. I wouldn't go back, plug it in. The only time I would is if this here, we do this, we would subtract, because 2y minus 2y is 0. Negative x minus 3x is negative 4x. Okay. 2y minus 2y is 0. 4z minus negative z. Well, the negative make a positive 5z. Negative 9 minus 7 is negative 16, yes? Okay. Questions on this so far? So, we had one equation with one variable. Now we have the second equation with 2. But we already know what x is, yes? I don't have to eliminate another variable out. I already know what one of those two is. I know x already. So since I already know one of the variables, we can plug it in. Negative 4 times negative 1 is 4. So we have 4 plus 5z equals 16. At this point here, we can minus 4 from both sides. Scroll down. Telling us that 5z is equal to make sure. Yep. That doesn't seem. Yes. Thank you. Yeah, because I'm like, that does not seem right. And it's not. It should be negative 16, giving us negative 20. Divide both sides by 5. Telling us z is equal to 4. Negative 4, but yes. Part of the reason I was pausing on that is because I've done this problem 3 times today. Z has come out as a whole number, or an integer every single time. So it should be an integer this hour. Questions on how we found x or z? Now we need to find y, yes? So we're going to take one of the 3 equations, our original equations, and plug this back in. Which equation do we want to use? Top one. So we plug negative 1 in for x, minus 2y, plus plug negative 4 in for z. So plugged x and z in. Now we're going to solve for y. So we'd have negative 1 minus 2y minus 4 equals negative 11. Now we can combine our like terms. Negative 1 minus 4 is going to be negative 5. Now at this point here we can add 5 to both sides, telling us negative 2y equals negative 6. Last but not least, we can divide both sides by negative 2, telling us y is equal to 3. So our solution is the point negative 1, 3, negative 4. Questions on this here? Two more. Be ready for the next one. All right. This one here, x, y, and z, again, just like the last one, all of them are pretty good choices for eliminating one of the variables out. Because I can easily turn x into 4x, or our top x into 4x and 3x. Same thing with y. I can turn y into 2y, y into 4y. And I can turn z into negative 4, 4z, and z. X, y, or z, which one do we want to eliminate first? X. Okay. So since we're using x, we would want to use the top equation as our eliminator equation because we can easily turn x into 4x by multiplying it by 4 and x into 3x by multiplying it by 3. So the equations we are not using as the eliminator equations, we'll rewrite them here. Questions on this so far? Now the one on the left, what do we need to multiply that equation by, our eliminator equation by, to get the x's to be the same? What do we need to multiply this x by to get it to be 4x? 4, yes. So we can distribute the 4. 4 times x is 4x. 4 times y is going to be plus 4y. And 4 times negative z is negative 4z. And 4 times negative 1 is negative 4. And then we can take that equation and plug it and under our other equation on the left. Now the question is if we're going to add or subtract. 4x plus 4x is 8x, yes? Is that what we wanted? No, we wanted it to be 0 because that's the one we're eliminating, yes? So 4x minus 4x is indeed 0, so we're going to subtract all the way across. 4y minus 4y. Negative 4z minus negative 4z. 0. So that entire left side of the equation is 0. Negative 2 minus negative 4. Well, the negative would make a. So negative 2 plus 4 is 0 equal to 2. No solution. As soon as we get a false statement, it doesn't matter where we are in the problem solving steps, we're done. Because it means that those two equations, those two planes, do not cross, they do not intersect, we're done. Because again, for it to be a solution, it has to intersect all three, and if two of them don't cross, that's it. Questions on this here? Last one. This here. Do we want to eliminate x, y, or z first? Z? All right. top or middle equation for the eliminator equation? Top. Because it really doesn't matter which one we eliminate first. We'll do z. I would have done y normally, but why would I have done y? They're already all the same, yes? But it doesn't matter, because to get x's to be the same, well, for this top one and the one on the left, it's already the same, yes? Let's see here. That should be plus. So we have x plus y plus z equals 8 as our eliminator equation. We don't have to do anything to it. Since the signs are the same, we're going to subtract. X minus x is negative y minus y is negative 2y. Z minus z, 8 minus 8. Well, at this point here, we can just go on and solve for y. Y equals 0. Now, we will have to multiply our eliminator equation by a number to get its x, to get this x and this x to be the same. So we're going to have to multiply our top equation, all of it, by 2. 2 times x is 2x. 2 times y is plus 2y. And 2 times z is plus 2z. And 8 times 2 is 16. Would we add or subtract? We'd subtract, because 2x minus 2x is 0. Y minus 2y. Almost. Negative y. 1 minus 2. Now 2z minus 2z is indeed 0. 16 minus 16 is negative y equals 0. We can divide both sides by negative 1, telling us y is 0. So both equations verify that y is indeed 0. That's kind of odd, isn't it? Okay. I'm going to look back at these three equations here. I'm going to plug y back in as 0. Well, if we plug 0 in each of these y's, it's just going to become 0. So the top equation with 0 plugged in as y is going to become x plus z equals 8, yes? The second equation, if we plug it in, we get x plus z equals 8. Are those the same equation? Yeah. And the last one, if we plug in 0 for y, we get 2x plus 2z equals. Well, that's the same equation, isn't it? It's just multiplied by 2. So we know that these are all the same equation, yes? Well, this is infinitely many solutions. Now, as you're saying, x could be 4, y is 0, z is 4, yes? How about 2, 0, not 2, 4. Because 8, 8, no, it wouldn't be 8, 4. 6. Because the top two, 2 plus 6 is 8. 2 plus 6 is 8, yes? The bottom 2 times 2 is? 6 times 2 is? 4 plus 12? Almost. One more. 16, yeah. That gives us another solution, yes? 2.5. 2.5 plus 5.5 is indeed 8. 2 times 2.5 plus 2 times 5.5 is. So again, there's an infinite number of solutions we can have. And this one here, it's going to follow, because it'd be, let's see here, x, 0 for y, and then it's going to be negative x plus 8, because we'd have to subtract the x over for z. Now, most likely, if I remember right, the book actually has it as z, yeah, or just, it's just the other version with, it'd be negative z plus 8, 0, z. But this is the set equation for infinitely many. I just need you to tell me it's infinitely many. Are you ready for the next piece? Homework. Problems 3 through 5, 11, and 13.